Hi everyone, my name is Rayyan Alavi and today I'll be presenting exercise number 2 from assessment 3 from the business forecasting unit. For this assessment, we took the original data private sector from ABS dwelling building approvals and applied a multiple linear regression based model in order to forecast the next 12 months from July 2024 to June 2025, carrying on from the actual data we already had, which was from July 2015 to June 2024. Now, this model incorporated monthly dummy variables in order to capture both trend and seasonality fluctuations. Now, for the scope and application section, as I mentioned, the objective was to forecast the next 12 months. Um, the we used the regression model on Excel from the data analysis tool pack. Um, on the y-axis, we put the actual data, which is a dependent variable. On the x-axis, we had the time component and the monthly dummies, which represented the independent variable. I will now take you straight to my Excel, where you can see my results and how I completed the exercise. So I now demonstrate on Excel how I completed exercise number 2 and develop my regression-based model, multiple regression linear model. So in this exercise, we incorporated monthly dummy variables from column D to N to capture both the overall trend and seasonal fluctuations in the private sector dwelling approvals. So in column B, we have the actual data. In column C, we have time, which goes up by 1 each row. And D to N were the monthly dummy variables from January to November. We excluded December as we used this as the base month. Now basically how we ran the regression was we went to data analysis, and then we brought up the regression table. In the X range, we included the time and dummy columns. In the Y range was the actual data. We ticked labels so it includes the headers, and then clicked OK, and output range Q1, we managed to get this table. Now the output shows an intercept of 18345.94. The time coefficient is minus 53.48, which represents and indicates a slow downward trend. In the approvals, the R square is 0.53, which means the model explains only about half of the variation in approvals. Now, interpreting each monthly coefficients, they represent how much higher or lower the month's approvals were compared to December. For example, May, as you can see, was plus 2,319, and November was 2,256, which shows strong seasonal peaks during those periods, while January was the lowest month with a significant dip. So this basically confirms a repeating seasonal cycle that matches typical construction patterns in Australia. Now, to generate the forecasts and calculate the fitting values and the extended 12 months forecast for July 2024 to June 2025, we applied the intercept, the time, and the relevant monthly dummy coefficient to predict the approvals for each month. So, as you can see here, we have a graph which shows the actual values versus the forecasts. So, the forecast continues a seasonal pattern with dips around December and peaks around May. So from the out of sample forecast, we can see that December displays significant peak while it picks up again in May, which shows that the model clearly captures both the downward trend and the recurring monthly cycles. Overall, this regression model provides a clear, interpretable seasonal forecast that is fairly reliable for short-term planning and aligns with observed building industry cycles. However, it may not be so effective in the long term due to it not including key factors such as inflation, construction costs, and policies, government policies, which can have a significant impact on building approvals. That concludes the Excel demonstration. We will now move back onto the slides to further discuss the evaluation and business implications this model can have. So now for the analysis section, as you can see, we have the chart for the actual as forecasted approvals. You can see the model follows the overall pattern fairly closely, capturing the rises and dips, though not every short-term fluctuation. Um, the second chart displays the next 12 months forecasts, and it shows how approvals are expected to move into 2025. The model predicts a massive dip around December 2024, followed by a steady rise peaking around May 2025, which matches typical mid-year construction trends, which have been historically observed. The R square value also shows that while the model fits moderately well, there are still external economic factors that normally influence building approvals outside of seasonality and trend, which are not captured. Now, for the articulation of issues, so I checked for several model diagnostics. The residual plot showed no real strong trend, meaning the model doesn't systematically over or under forecast. One monthly dummy was also omitted to avoid the dummy variable trap. There is still evidence of autocorrelation suggesting the model doesn't fully capture lagged effects. For example, approvals in one month which could influence the next month. Now, compared to the Winters model from the previous assessment, this regression model is more interpretable. You can clearly see which months contribute to seasonal highs and lows and how approvals trend over time. However, I think Winters was slightly better at adapting to recent changes since it updates automatically each period. From a forecasting perspective, the regression model works well for identifying seasonal timing and underlying trends in the short term. Um, but however, from a business intelligence perspective, it does offer transparency and key insight into drivers of change. But for better accuracy and long-term effectiveness, it should be combined with external variables like interest rates, costs, construction costs, and inflation. So I would recommend this model as a strong baseline for the next year or so, suitable for housing and construction. However, I wouldn't recommend it for the long term.